So, it's been a while. Let's have a look at this, shall we? So we need to warm up, and that involves moving to these targets. Start off moving very slowly. And as you move more and more and rotate more and more, you get quicker and quicker. And this is all part of the learning a skill idea. You know, you don't pick up upgrades, you practice. Anyway, that's warm up completed, right? So now I can move around reasonably quickly. But, you know, no great shakes. The thing I wanted to show you today was the envelope. So we've got hover, which is your jetpack. And as you can see, well, you can't see actually, but I'm holding down the space bar and I can't stay up. And the reason for that is over here on the left-hand side, I've got an envelope on thrust. I talked about my envelope idea, you know, using concepts from modular synthesizers in video games. I've also got a modulator, which is way more powerful than an envelope, but I'm not hooking those up. And the way these talk to each other is that you pass float variables, another thing that I discussed in an earlier video. And the float variables allow you to easily hook up one module to another, like a patching system. Yeah. So here's a new unit, a new module, if you like, called overdrive, and I've attached the overdrive to the hover envelope. Here you can see that after an initial quick attack and a slow release, the sustain level is fairly low, about a third. And that means that your maximum thrust level after about half a second will go down to about a third. So that's enveloping of the thrust. The overdrive, what it does, I mean, it sounds really fancy, but actually it's very simple. It's just a scalar. But I'm calling it an overdrive because that's the concept I'm familiar with from the world of music. So what have we got here? So the overdrive level is 20. Are we still playing the game? We are. So if I change overdrive to 50 and go back here and then thrust, as you can see, disappears completely off the screen, should come back down eventually. I've no idea. Yeah, there you go. So 50 is way, way too much. But all that's doing is it's taking an input, and the input is here, and it comes from this, the hover envelope. So the hover envelope, as you can see, has got this output here. That's the float variable called player hover power. And that is also here. So what this does, the overdrive, is it takes input from the output of this envelope, and then it applies overdrive, which is it scales it. And let's put that back down to 20, not that it matters for now. And then it outputs it to this, which is the final value. That final value is then fed into the player's vertical thrust. I'm not sure you can actually see it, but you can see the results of it in the Y acceleration. So there, as you can see, once the envelope settles, Y acceleration goes down to about 7.22, which, as you can see, is not enough to escape gravity. So if we increase the drive level to 30, you'll see that that now goes up to 10. Obviously, it starts off much higher because of the envelope, but then settles at 10. But that's more than enough to escape the effects of gravity. Let's put that back down to 20. So this is all very, very simple stuff, but it's a neat way of thinking about how to control certain player variables, because it's stuff that we do all the time, and it's a pain to do it manually. And modular synthesizers are a nice way of thinking about this. Let's have a look at some code, shall we? Something new. What did I do? Oh yeah, really simple thing. Let's go to game and open up that script. It's a nothing script, but so one pattern that I find myself using an awful lot is checking the state of input to see if it's changed from the last time round. And if it has, then do something. And what you do is going to change depending on whether you flipped to positive from negative or to negative from positive, but not when the values are the same. Now, you do that enough, even in demos, I thought might as well chuck in a really simple class to deal with it. I have no idea why Ride is taking so long to load up. I think it's got something to do with the M1 chip on the Mac and Ryder not liking all the Rosetta stuff. So that's my Quest class. I don't know why it's opened up the Quest class when I've clearly opened game. Okay, there we go. It's switched to game now. So the class I wanted to talk to you about is called Buffered Bool, and I'm still waiting for this to load. Here we go. My goodness, this is slow today. Truth be told, I've actually been working on my Alienware Area 51, which is, I don't know, a 6-year-old machine now, but it's still really capable. Very impressive machine. I'm very, very pleased with the machine. Let's go into scripts. And yeah, you can see this is not what you would expect, right? And where's Buffered Bool? Here we go. Wow, that really is slow. My apologies. Might also be because I'm running ScreenFlow to record all of this. We'll see. So Buffered Bool, what does it do? Well, it's got these things, these bools that tell you if we have switched to positive from negative and also if we switch to negative from positive. And it's also maintaining an update list so that you don't have to do the write back of the current value to the old value for every single buffered bool in your frame. Ideally, what you'd have is you'd create an object specifically for all buffered bools at the opening of a function, and then when you left that function, the object would be destroyed, and before destruction, it would do all of the write backs. But that's it just garbage or whatever. So very simply, this allows me to treat the value, the main value, as just a bool. And here we set the value. I've got a holding variable called purgatory, which I think is an excellent variable name. I highly recommend that you use that. A variable will always stay in purgatory unless you explicitly update the value at the end once you've done using it. So really simple, right? So what it does is when you set the value initially, this is the new values. Let's say, for example, you're checking a key press. You pass the key press to the buffered bool and you go set. And what it does, it first of all saves the previous value and then sets the value to current. And here's a useful method that takes two methods which are executed whether the phase switch was to true or to false. They're really simple. And here's an even more complete function which does a combination of setting the current value while also switching depending on whether there's been a phase transition from false to true or true to false. And finally, this is what you should call at the end of everything, which is to update the backed or buffered value of the bool to previous. Really simple. And that's pretty much it, really. I think, yeah, update all is the static. So it goes through the list. So if you can't be bothered to do an update on each of the buffered bools, it will then basically go through the entire list and write the backed value from purgatory back to previous. So that's pretty much it. Yesterday was a very productive day. You can probably see here I'm using, it's got really generic name. Dialogue System it's called, by Pixel Crushers. They're fantastic, by the way, totally recommended. They have such superb support. Very, very happy using them. That's the update for now. There were a few other things, but we've done enough, I think, for today. And have a good weekend.